to give it a shot? Can you give it a go?
Go for it.
Thanks.
Okay. Can everyone hear me then?
Yeah?
Okay, fantastic. Okay, so thanks for having me along to chat about Rancher, and I never like to do meetups where I just feel like I'm coming on to do a sales pitch about Rancher, because it's not what I want to do. So what I've done is I've sort of tied it in with enterprise considerations, so things that you need to think about when running containers, not necessarily just Rancher, but container infrastructures in larger organizations and wanting them to be production ready. So I'm the director of field engineering for Rancher Labs. I've been with Rancher for 2.5 years, and prior to that I was actually a DevOps lead and implemented sort of containers and Rancher within the organization, the NHS, which you may well have heard of in the UK. So I know about running containers at scale. So what I wanted to do was basically give you some background and learnings and things to watch out for when running containers at scale and in production. Happy to take questions whenever people want to spin up with questions. And then I was just going to give a sort of a quick demo of 2.0 and how it can help solve some of the problems that you can potentially encounter when running containers in larger organizations. I haven't got many slides. I've only got like 3 or 4 slides. I'm not a big slide person. I'd rather talk about things. And it'd be nice if there was a little bit of discussion and understanding what challenges people are actually facing, just making it a little bit more interactive. But we'll see how we get on. Okay. So these 6 items are probably the biggest questions, areas that we get asked questions around when actually trying to deploy container infrastructures into enterprises for production use. Now, I've got storage at the top. Storage is one of those things that I still don't believe containers have a brilliant solution for. So persistent storage, when Docker and containers sort of first evolved back in LXC days in 2008, and more sort of recently in sort of 2013, 2014 when Docker came to light, they were primarily aimed at trying to solve the problem of running stateless web apps. And they did that very, very well. They allowed for very rapid production of artifacts, containers that could be spun up and replaced very, very quickly, upgraded very quickly, and they work brilliantly. And that use case is still the perfect use case for containers. What people wanted to do, though, was they saw the ease with which you could spin up new applications and the improvements in sort of the developer workflow, the developer's life cycle, and so they wanted to mangle what was sort of originally sort of designed for these stateless services and try and run everything in them. So in sort of my background, I've done dev, and what we found was Docker was one of those technologies that people adopted because it made their life easier. And I'd say 3.5, 4 years ago, Docker was primarily, or adoption of Docker was primarily being driven from sort of the devs. Now what's happening is you've got the sort of Kubernetes and sort of the backing of Google and all of the news sort of around sort of containerized infrastructures and the benefits that they bring. And every conference that sort of the CXOs go to, they get this rammed down their throats. And what they do is they come back and force it down onto the devs and say, yeah, we're going with Kubernetes. Not necessarily understanding what the sort of the challenges around doing that are, but it's the latest sort of buzz. They know that it's going to save them money in the long run and everything else. So most of it's true, but there is a lot of hype around it. But again, storage is one of these areas where they've sort of come along and they've said, okay, well, we want to move all of our infrastructure into containers, and databases and file servers and everything else. And I've come across so many companies that have tried to do this and failed, because the solutions that are out there at the moment are very niche solutions. They're based on trying to mangle Docker into doing things that it wasn't originally designed to do. And I've got no doubt that sort of storage is coming. It's where security was a couple of years ago. So the two top things have always been security and storage around containers. So storage, there's a few solutions out there. You've got sort of the Rooks of this world with the open source and Ceph running underneath it. You've got the Storage OS, which is sort of proprietary, and Portworx, which have their own proprietary solutions for trying to sort of manage storage and manage persistent state within containers. And then we've got Longhorn, which is a Rancher product, which is it's all about basically creating a RAID 0 for containers. So it's about protecting the data. So what I've always tried to sort of steer away from when I've gone into enterprise organizations is I've tried to steer people away from moving everything that requires persistent storage into containers. If you've got a sort of a pool of database administrators and you've got a server farm that's dedicated to it, that's the best place for storage. Best place for databases to run. Don't try and mangle sort of Docker to do things. Keep it simple. Certainly if you're just starting down this road in adopting containers, try and leave persistence behind. Try and consume persistence where it already exists. So if you already have NFS in an organization, consume it from there. It may not be that sort of the cloud native storage solution is the way that you need to go. And like I say, I've got no doubt in the next couple of years we're going to see a lot more movement in this space, and it will become a lot better. But it's more around education and trying to sort of make things easy, make your life easy, and make make containers successful for you in your organisation. The second sort of one on this list is RBAC, and I bundle all security in with RBAC. Security has been one of those challenges, I think, where people have moved from sort of full-fat VMs and legacy sort of hardware servers, and the way that you do things is slightly different in sort of the containerized world. Things don't work quite the same, and it goes for most of the things on here. They don't work quite the same. So the security, a lot of the organizations we go to, they've got their CISO folks who have it set in their head how security should look for an application. But it's stuck in the old ways. It doesn't take account of the way that containers run and the way that containers can run on any bit of infrastructure. And yeah, you can really tie it down, but then actually you're losing a lot of the benefits that you're gaining from moving to a containerized infrastructure. So what I would say with RBAC is, this goes for any kind of RBAC and security really, keep it simple. Don't try and overcomplicate the RBAC that you've got in there. So Kubernetes has introduced sort of a very granular RBAC, so you can lock everything down if you really want to. But actually, administering that becomes a burden on you guys. I'm assuming that you guys are doing the running of the infrastructure, and there could be some devs out there who are going, I don't really care about RBAC, it's not my problem. But RBAC, don't overcomplicate it. I mean, I come from a background within the NHS, and every sort of doctor has got a smart card, and they have a bunch of roles associated with that. The permutations of the number of roles that we had to support 1 million users was in the billions. And you can imagine actually administering that and reporting on that, it just became overly complicated, when really you probably got away with 100 roles, because the majority of what people are wanting to do is going to be very similar. So when looking at RBAC, just consider what you actually need to do with RBAC. Make sure that things have only as much permission as they need, but don't make it overly restrictive so that every single person has their own RBAC policy, because it just becomes a waste of effort. Server distribution. What I mean by server distribution is where you're actually going to place your resources. So depending on where you're running, you may have multiple data centers. You may be running in multiple data centers around the world. Your application may just be running on a single server. This is primarily aimed at sort of Kubernetes, which is where sort of all of the containerization is going. We know Kubernetes has sort of taken over and has become sort of the orchestrator of choice. But there are a few sort of things that you have to consider when you're looking at how you're going to deploy your actual application. Physics being the primary one. So etcd is very sensitive to latency. What you can't do is create a cluster that spans multiple geos. What you'll find is you'll start getting lots of failures and retries, and it may be that actually your application, whilst people are building microservices, people tend not to build microservices for high latency environments. The more and more places that we come across that are doing application distribution across sort of clusters, they're looking to reduce the latency and reduce it to the point where what they're doing is running actually a single instance of all their applications on a single server, and then actually mangling the sort of the network so that all communication goes through a single stack on a single server, just to reduce the latency within their application. So etcd hasn't been built to withstand high latency environments. So when you're looking at how you're going to create your infrastructure that you're going to run this on in your enterprise, be wary of how you're going to distribute sort of the application and the underlying sort of infrastructure required by Kubernetes. It can be a challenge. So I don't know how many people in the room are from global organizations and how many are just sort of running in a sort of a single DC or a couple of DCs a few miles apart. But just one of the things to consider. The other thing to consider with server distribution is with Kubernetes, 2 is a really bad number. Kubernetes likes odd numbers. So etcd, again, you need 3 servers for it to be highly available. 3 and 2 aren't a good number when you're trying to make something highly available in Kubernetes. So the way that etcd works is it works on a majority. So if it doesn't have the majority of its nodes available, it goes into a read-only mode. So what happens with your servers is, if you've only got 2 data centers and you've got 3 etcd instances running, 2 of those instances run in one data center and 1 instance runs in another data center. If you lose your data center that's running your 2 instances, it automatically takes out your other data center as well. So when you're looking at how you're designing your infrastructure, be wary of things like how you distribute the services that run along with Kubernetes. In the instances where you've got 2 data centers, you're actually better off running discrete clusters in each data center rather than trying to span. Okay. Monitoring and alerting. So, as I said before, the way that you do things in a containerized world is very different to the way that you do things in a sort of a full fat VM and hardware PC server environment. The monitoring tools that you will be used to typically don't work so well in containerized environments. So typically what you'll have is some sort of CMDB that feeds a monitoring tool that builds up a static list of servers. It knows what application is running on each one of those servers, and it's monitoring that. So it knows that when that particular server goes down, this is going to happen within your application. When you move into a containerized world, typically what you're doing is you don't actually care where things are running. You've got a bunch of resources, compute resources, so just some RAM, some disk, and some CPUs spread across a number of physical hosts. But actually, you don't really care about those physical hosts. All you care about is the capacity and making sure that there's enough capacity in that bunch of compute to run the number of instances and servers that you want, services that you want to run for your application. So one of the things that people have a difficulty in moving from sort of the old way of working to sort of containerized way of working is understanding how you need to change your monitoring. And the monitoring, you re-envisage it, and basically you start thinking about monitoring services. So you actually want to monitor your end-to-end sort of application and have deep pings through your application to ensure that your application's up and running. You no longer care about monitoring servers, other than if a server's there now, it might not be tomorrow, but you don't really care so long as you've got enough capacity, because Kubernetes or your scheduler will take care of sort of running your application at the scale that you've set it. So one of the difficulties in getting, or one of the difficulties in gates that you typically have to go through when you're trying to get containerized infrastructure into production is getting it through your ops guys. So be very open with the ops guys in that they need to change the way that they work, and you need to be open to sort of helping them understand what they need to do to actually get this stuff into production. And make sure that when you're talking to people, you get people involved early. Don't leave it till the last minute and think, all right, my application's done. I know it all works great. I'm running in a containerized infrastructure. I now need to figure out how I'm actually going to get it in production. Start the conversations before you even start developing your actual application. There's a lot of departments that you will need to speak to before you get into production. So you have to speak to your ops guys, you have to speak to your procurement guys, you'll have to speak to the security guys. You need to get all of these guys on board, otherwise your application is actually going nowhere. So think about when you're sort of trying to get these things through, it's not just a technical problem. Technical problems typically the easiest to solve. The politics and organisational problems are the ones where people sort of fall over when trying to get containers into production. And monitoring and security are probably the two biggest areas where you will get pushback. Because the ops guys who are there at 3 o'clock in the morning monitoring your application, they want to be happy that the dials that they're seeing are representative of the application. So typically you'll find very strong gates getting through those. Similarly with security, depending on the data that is running within your application, it can be very challenging getting security guys on board and sort of signing off on a new way of doing things. The number of places where I've been where they want to basically put everything through intrusion detection at every layer, you can't do that effectively within containers. If you're going to start trying to make your container infrastructure look like your old server architecture, then you're onto a losing streak for a start. You're never going to get anywhere. So you need to work with these guys right from the start and keep them informed and get them going to conferences about sort of containers and Kubernetes, so that they can sort of bust the myths that Docker and containers are insecure and difficult to manage, because it's not that hard. Alerting is another thing. So alerting is not typically as challenging as monitoring, because most things you can send an alert via a webhook or some sort of agent that can be installed. Provided you can integrate into that, then you tend not to have as much problem. But I put monitoring and alerting in there because they tend to be sort of bundled together with the same teams sort of looking after them. Okay, application deployment. Think about how you want to deploy your application. So when people move to microservices sort of development and agile working, what they typically tend to do is devs will start with it on their laptop and they'll use Minikube or something deployed locally and they'll get the app up and running, and that's at the point they stop doing anything. After that, it's up to the infrastructure guys to figure out how they're actually going to run that in production. So you've got products like Rancher which help you sort of manage a Kubernetes environment, but actually how are you going to get your application onto those sort of onto that environment, onto that actual infrastructure? So it actually starts before this, in that you've got to get your teams on board with doing the application development in a way that sort of suits agile working to start with. So that's a whole different talk. But when you're doing the deployment, a lot of places that we're seeing now, so I'd say go back 3 years when there wasn't really tight integration between CI/CD pipelines and sort of Docker deployments, people were doing it with a bunch of scripts and sort of automating it that way as best they could. So you'd have your CI/CD build something and it'd give you an artifact, it'd then be moved to somewhere where it could be accessed, and then your scripts would be run to actually do the upgrade. But it was sort of one of those things that could be it could be quite labour intensive, and people had to sit and watch these things to ensure they went correct and all the rest of it. Now what we're finding is that CI/CD has actually come a long way and integrates directly into Kubernetes very nicely. So what people are trying to do is basically automate the sort of the code check-in, the build of the code, the testing, unit testing of the code, even having it deploy out to some test environments and running like Selenium tests against it, and then sort of once it passes through a bunch of automated gates, it can then actually deploy out into production in an automated way as well. A lot of places aren't at the the stage of being able to automatically do the deployments through to production. Typically, again, this is a process thing, it's not a technical thing. Most places have have to have some sort of two-stage sign-off, so there's a change control meeting whenever that says yes or no. Tests have to be involved and say whether or not they think it's fit for purpose, and then you actually get the deployment done. But actually, that bit's sort of fairly easy to sort of work through once you've got your application working and doing the deployment. So have a look at the way that you're wanting to do the application deployment. Some of the CI/CD tools that are out there integrate very nicely, others not so nicely, but you can still automate the production, automate deploying that into environments using scripts and queue control and various CLIs that will allow you to actually deploy through and trigger off tests and everything else. So just have a think about how you want to do that application deployment. And the last piece is really around provisioning. So it's the actual provisioning of the infrastructure that you're going to run your containers on. So there's a lot of sort of ways of doing this with infrastructure as code. So there's some great tools out there using Terraform, Ansible, Chef, Puppet are all ways that are sort of regularly used doing provisioning through to these environments. But typically when people are moving into sort of the containers, they tend to be moving from running on-prem to cloud. Now, there's always exceptions to the rule, and I would say at the moment we're probably seeing 50-50 movement to the cloud versus running locally in a data center. But it depends on sort of the company that's doing this as to which model works best for them. But provisioning, again, doesn't necessarily work with the same tools that you had before. It's typically not as jarring a change as, say, the monitoring, but you will have tweaks that need to be done with sort of the way that you provision infrastructure and permissions and keys and everything else that goes along with it. How you're actually going to provision your Kubernetes infrastructure and sort of control the security around that. All things that need to be considered when actually trying to get this out into sort of a production supported environment. So that's really what I wanted to go through on the production considerations. Is there any questions in the room around that?
Questions? No? Doesn't seem that way?
No.
Just a quick one from me. So
yeah.
A lot of the information that you mentioned is primarily around Kubernetes. And I know
Yeah.
that the Rancher has that cattle feature.
Yeah.
What's the primary difference between cattle versus Kubernetes?
So Cattle was the orchestrator that we had in our 1.x product line. So what Cattle was it was based on the Docker Compose format. I mean, everything we run is still on top of Docker, it's just running Kubernetes. But with 1.x, basically what we wanted to do was we wanted to make Docker consumable. So it used the Compose file format, and it was basically our own orchestrator. So within our 1.x product range, we supported multiple orchestrators. So we supported Swarm, Kubernetes, Mesos, and Cattle. When we've moved to 2.0, basically we've moved completely to Kubernetes. It was odd because a couple of years ago, most places that we were going to, when you were talking about sort of containers, most people will refer to it as Docker. We want to run Docker, okay? We very, very rarely now hear Docker mentioned because people have moved on to, we want to run containers. And containers are sort of becoming more and more associated with Kubernetes, I think, than sort of Docker. So Docker's the runtime that runs everything underneath anyway. But most people are sort of more familiar with Kubernetes as an orchestrator than Swarm as an orchestrator, especially since sort of Docker have now jumped on board and they're offering sort of Kubernetes as well as Swarm. So what Rancher have done in the movement from the 1.x product line to the 2.0 is we've moved away from supporting our own orchestrator. There was no real value in us supporting Cattle any longer. So it's still great for sort of small environments where you're wanting to run maybe on your laptop and you don't want to turn it into a big heap box, because that's what Kubernetes seems to do. It's very lightweight, and it made running containers very, very easy. It gave you a nice UI to do this with, and sort of made it simple. What Kubernetes has done is it's been very well developed, it's very well architected, but it's overkill for the majority of use cases. So it requires a little bit more sort of feeding and watering than things like cattle and Docker Swarm. So the setup of it is more convoluted, but it's very powerful and very flexible in that you can make it pretty much do anything you need it to do with a little bit of work. It's just not quite as easy to get up and running. So we do have, I don't know if anyone there sort of follows our chief architect, Darren Shepherd, on Twitter or anything, or sort of attends any of our meetups, but Darren is working on a new product that we're going to be offering. He's put out an alpha version of it already on GitHub, because it's going to be open source again, called Rio. And what Rio is a way of, he's trying to bring back the simplicity of Docker, but using the power of Kubernetes. So it's going to use service mesh. I'm not sure what he's using. It was Istio. I think he might be moving to Linkerd too. But it's basically a way of running containers very simply. It's very lightweight. It doesn't have a UI or anything else. It's all command line, basically how Docker started originally. And it will integrate into our 2.0 product line. But he's seeing that more as our replacement for cattle than sort of us maintaining an orchestrator going forward. So what he's doing is he's leveraging other technologies that are out there, part of the CNCF technologies that are already out there, and basically trying to make it easier for people to consume containers again. Does that answer the question?
Yes, thank you.
Yeah, no worries. Okay, so I'm going to move on to talk about Rancher in a little bit more detail. I'll give you a sort of a brief demo. I'm happy to show people whatever they want. If this is not what people are interested in, then I'm happy to shut up and go away now. But I'm quite happy to go through giving you a sort of an overview of what 2.0 does and what it adds on top of sort of Docker and Kubernetes. Like I say, I don't really want to go into it as a sales pitch. I'm not sales. I'm a technical person who's just talking about the product that we offer and how it can actually ease with some of the things that I sort of discussed in sort of the getting this stuff into production. So primarily around things like the authentication and the RBAC and centralization of that and the provisioning, we add in what sort of run all of these things as part of 2.0. I can give you sort of a walkthrough of those. So we split sort of the 2.0 into three separate bits. One is around provisioning. So we can provision to bare metal, we can provision to vSphere, or we can provision to and sort of manage and run cloud-hosted Kubernetes clusters, so the EKS, GKE, and AKS. Or if you've already got a Kubernetes cluster running, you can actually bring that along and we can sort of import that cluster and give you all of the sort of power and management capabilities that Rancher brings along with it. The next level up that we've got there is around the unified cluster management. So this is part of it's the provisioning of the other infrastructures. Centralized authentication is one of the things that enterprises are coming to us for more and more. When you start getting into multiple clusters and administering multiple namespaces, authentication can become quite painful, and administering all of those can be quite painful. What Rancher allows you to do is basically set a single authentication provider, be it LDAP, Active Directory, FreeIPA, SAML, a whole bunch of them. Basically what you can do is you can tie a single sort of Rancher management server to a single authentication backend, and then any clusters that are managed by that Rancher installation will allow you to utilize the user accounts that are within that directory down at the cluster level. So you don't have to go around provisioning user accounts into each cluster and setting permissions and everything else, because you can do that all from a sort of the central Rancher management control plane. The RBAC, so we actually surface all of the RBAC that Kubernetes brings along, and it's a very powerful, very granular RBAC model. Goes back to what I was saying, don't overcomplicate it, but the power is there if you want to. So what we do now is we surface all of the permissions that Kubernetes gives, and that sort of give you a nice UI to manage all of those. And you can define a role once, and use it in multiple places, so you can use it across multiple clusters, but you only have to define it once, rather than having to define it for every namespace or every cluster that you're using. We do policy management, so you can manage network security policies and pod security policies centrally. So again, any clusters that are sort of pushed out there, you can enforce these sort of rules down onto those clusters. Where we've seen this used is for places that have imported clusters. So they've gone in, they've decided they're going to go down the Rancher route for doing the management of their Kubernetes clusters. What they'll find is they'll find little pockets of Kubernetes that have been spun up in various parts of the organization. One way to bring them in line with sort of the policy and security requirements that you've got is to basically import them. So it doesn't disrupt the applications that are running there. The guys who were running with them before, they might have to change how they authenticate, but apart from that, their applications are still running. But it does allow you to enforce some consistency across the way that the Kubernetes clusters themselves are run within the organization. Capacity, we give you sort of a view of the capacity that you've got within your cluster. So we give you a dashboard that shows you how your cluster health is looking, so how many pods you've got running, what the CPU and RAM utilization across your cluster is. The cost piece we haven't integrated yet, but it's coming in a future release, so you'll be able to sort of use it for chargeback at some point. And then the next level up that we've got there is around the workload management. And I think this is where sort of Rancher adds the next level of sort of usability to Kubernetes. So it gives you a nice user interface. For people who've used the Kubernetes dashboard, that was a dashboard that was developed by developers for developers. It was functional, but it wasn't necessarily pretty. The user experience isn't necessarily the best. It's nice and it works, and for devs it's great. But for ops people, it wasn't so useful, it wasn't so friendly. So what we've tried to do with 2.0 is basically, we've tried to make a product that fits both use cases. So not everywhere has DevOps. Most places have devs and most places have ops, and there's sort of a line between them. The dev guys you will find are very technical, they're the guys who develop the applications, and typically they're the guys who support the underlying infrastructure. And then you've got the ops guys who are the guys that typically are running your actual application. So doing the deployments of the application at 2 o'clock in the morning, monitoring the application to ensure that sort of people are getting responses on the website or whatever else. So what we've done with the workload management is we've tried to facilitate both sides. So the application catalog is another way of, I'll give you a brief demo of the app catalog. It's a way of basically publishing applications that have been developed by a team for consumption by other teams with a very easy UI, rather than having to sort of understand all of the parameters and everything that necessarily need to be specified to get the application up and running. CI/CD, we've recently, well, in 2.0 we integrated pipelines into Rancher, so you can link it to a Git repository and have it watch for code checking. And then you can assign a bunch of actions where it will go away and check out the code, run unit tests, and basically compile the code into containers. In our current product, that stops at that point. With our 2.1 release at the end of this month, it actually goes all the way to allowing you to actually publish them to a local cache registry. So it'll create your containers, it will publish them to a cache registry, and then it will actually deploy them into a namespace and allow you to run unit tests, testing against them, automated testing against them, and sort of have that log back. So it's become a lot more flexible and a lot more powerful in 2.0. But we don't really want to tie anyone to anything. One of the things that we like about 2.0 and the whole thing around Rancher is we're open source and we're open to working with everything. We try not to be opinionated, so whilst we integrate some solutions into the product, you're not forced to use those products, so you don't have to use our CI/CD. We make it easy enough for you to integrate your existing CI/CD into the product, so you can use that. We've introduced some basic monitoring. This is going to be enhanced. So in 2.0 we actually include Prometheus Alert Manager out of the box. So it monitors the state of your cluster, and it can monitor the state of your application in terms of the number of instances that are running, and you can raise alerts based on that, and it'll alert out to Slack or PagerDuty or whatever other things Alert Manager will allow you to alert to. But we are going to integrate the sort of Prometheus product line more tightly with sort of Rancher 2.0. Typically, you'll find that the applications that we integrate with are CNCF products, so they're open source products that are part of the CNCF. We're typically trying to pick the more popular projects. So if you go to CNCF, Prometheus is by far and away the most sort of adopted monitoring tool that's in there. So expect further integration with Prometheus, and that should lead to sort of more informative dashboards and everything else within the actual UI. And then logging. So one of the things that we didn't have in our 1.x product line was a logging provider. So you could run FluentD on all of your servers and have it sort of running and publishing all of your logs through to various endpoints. We've actually integrated that now. So with a single option, you can set your login provider for your entire cluster, and rather than you having to specify it for every pod that gets launched, your default logging endpoint can be set with a single destination. So it could be that you want all of the logging to go direct to Splunk or Elasticsearch or Kafka or Syslog, rather than just going to the standard error, standard out that you then have to go to the container to get the information out of. So that in a nutshell is what Rancher's aiming to provide. It's basically trying to give you a complete container management platform for running your production services. So we're open source, as I said, and like I said, we're not opinionated. This slide's actually taken from one of our customers, and it's a rather large customer that's got a little logo that's got big black ears and has a basing in Paris as well as in Florida. And what they wanted to do was they wanted to allow sort of a common experience for running containers, but they didn't want to be restrictive in what they wanted their teams to consume. So teams have a bunch of options available to them. So as you can see here, Rancher will allow you to run on AWS or VMware or in Azure, and all of them are running Kubernetes, but they're all in different platforms, and sort of each team has its own sort of budgetary requirements and preferences, and they can do that, but they can do it in a controlled way where you've got central IT sort of enforcing the identity and the RBAC and the login, the monitoring onto these guys, but they still have the option to be able to sort of run this wherever they like, whenever they like, within that constraint. And Rancher gives them the ability to be able to do that in a consistent way. So it's actually very easy for them to switch between teams because they're still using Rancher. It's just the underlying infrastructure provider that's there. It's sort of at the choice of the team rather than being enforced from a central management perspective. So that's all I want to talk about Rancher. I was just going to run up a demo. Is there any questions on Rancher and what it does?
Chris, I've got one question. So
Yep.
with regards to your monitoring and your security there, do you guys have any platform within Rancher that actually monitors a container's workload rather than the application itself? The reason I ask is that something like that could be very useful for a security team that's trying to provide some form of security for their containers, but it's very difficult to actually provide security for the container itself. Rather, you'd provide the security for the workload and actually just secure that workload.
Yeah, so that's not one of the core features of what Rancher's trying to do. Now, there's a couple of products in the market that allow you to do that. One that we work with quite regularly is Aqua. I don't know if you've come across the Aqua security product.
Yeah, I've worked with that before.
Yeah, so Aqua's very powerful in that it will allow you, based on a bunch of policies, it will only allow certain containers to talk to other containers, it will only allow certain images to run, it will only allow certain images from a particular registry to run. So it's a lot more granular in what it can do. Rancher doesn't really go into the containers. All we run is containers. We don't really care what's running in those containers. So you have some control over what containers can talk to what other containers. So you can put in network security policies to disallow communication between certain applications, but that's to the level we go. If you're wanting sort of at a security level, you're wanting to sort of lock that down, then you have to go down sort of the Aqua or the Twizzlock type route. The other way that people are doing this is, depending on how you do your logging, you could use something like Sysdig or Datadog to actually generate sort of the logs and forward them through to into a console and have some rules around those that will sort of raise alerts but not necessarily stop the traffic, whereas Aqua will stop the traffic. So there's a couple of sort of players that are coming out. I'm trying to think of what the names are, that are going into more around the monitoring of your workload within your actual your containers. There's two ways of doing it, and the way that Sysdig and Datadog do it is they install a host agent that has very high privileges and can basically see into your container, and it can understand what code it's running and everything else. The other way of doing it is effectively you have to install code into each one of your containers, which is not necessarily the best practice, but it depends on the actual application. Building in an extra library so that you can do your security and login from within your application, it's sort of 6 and 2, 3. It depends on your requirements as to which one's the best solution.
Cool.
Aqua we've had a lot of success with. We've seen a lot of people move, sort of combine Rancher and Aqua for doing sort of the management of the Kubernetes clusters and then the management of the security around that.
Cool, perfect, thanks.
No worries. Any other questions? Okay. Okay, I'm just going to go through this really quickly. I mean, I don't want, like I said, I don't want it to be a sales pitch. I just want you to show quickly what the capabilities are of sort of using Rancher. So the main things that enterprises are interested in are around the authentication. So we've got a bunch of authentication providers that you can tie to. The roles, so we provide a bunch of roles out of the box that are the standard roles with a bunch of RBAC that are associated with them, where you can customize these roles, you can create new roles, and sort of, so I can add a cluster role, and I can add very, very granular permissions. And it sort of, all of this is just sort of sitting on top of the Kubernetes RBAC. We've added in some additional sort of features that you can manage, so it allows you to manage the Rancher aspects as well as the Kubernetes aspects, because Rancher does just sit on top of Kubernetes, but it's very granular to what you can actually go down to. One of the things that I think is really easy is the way that you can provision a cluster. So we will talk direct to sort of the hosted Kubernetes providers, so your GKE, AKS, EKS. So if you're wanting to run a hosted Kubernetes platform, we can tie into that. The advantage of doing that above just running it within sort of that cloud provider is they have native ways of doing things. So things like security, you'll be consuming the security that you link here. So if you want to be able to consume your Active Directory within an EKS cluster, you can't do that currently. You have to use Amazon user accounts. Whereas this will allow you to tie it to Active Directory. Not only that, you use that across all clusters that you're managing with your Rancher server. So you can deploy into EKS and AKS, and you've actually still got a single authentication provider, and you can apply exactly the same roles to both of those from the central console. Nodes, infrastructure providers, so your typical sort of EC2 virtual machines, Azure, DigitalOcean, and vSphere. We will talk direct through to the infrastructure provider, and we will basically manage the whole life cycle of these hosts. So we use a templating system, so you create a template that has sort of the credentials and the networks and security policies and everything else associated with them for a particular provider. And then what you do is you basically deploy your machines based on that template. So every time I want to add a new machine, rather than having to go through and specify all of those things again, I can just go in and add a new machine without having to go and specify all of that stuff every single time. So it makes it very easy to spin up a new cluster. So for example, I'll spin one up while we're talking. I'm just going to spin up an AWS cluster. I'm going to run all 3 planes on a single cluster, and that will just go away. I need to give it a name. That'll just go away, and it will create me a cluster. Okay. So if I go back into that, So if we give you a bunch of options that you can modify within the cluster, so you can run different versions of Kubernetes, you're not tied to them. So one of the disadvantages of moving to sort of the hosted Kubernetes is you have to run the version of Kubernetes that they supply, and we give you the option. So we run in parallel with sort of Kubernetes support. So Kubernetes typically supports its last 3 distributions, so that's what we're running with. So we support 11, 10, and 9 at the moment, and that's the same as Kubernetes, that's what they support. You have a choice of network providers. You can give project network isolation, so this is where a project allows you to administer multiple Kubernetes namespaces as a single instance, and we'll apply the sort of the permissions down to each namespace within it. By default, we now disable network isolation, so all of your projects on a particular cluster will be able to communicate with all other projects. You can turn on isolation so that if you want, say, a particular project to not be accessed and to not access other applications that are running in the same cluster, you can turn on this isolation, and it gives you that isolation of the applications at a sort of a softer level. You can use our ingress or not, it's up to yourselves. So the ingress is just a way of exposing your services out. By default, we deploy Nginx ingresses, but if you want to use HA proxy or traffic or something else, you can disable our ingress and spin your own. We're just sitting on top of Kubernetes. We don't interfere with Kubernetes in any way. It's a CNCF compliant full version of Kubernetes that's compiled from upstream. So anything you can do in Kubernetes anywhere else, you can do within Rancher. Metrics server you can turn on or off, pod security policy, requiring a specific supported version of Docker, and then you can specify cloud providers as well. So as I've deployed to AWS, I could specify the Kubernetes cloud provider for it. So rather than using our ingress, it would actually use it would use ALBs and ELBs rather than using Nginx for the deployment. So I've got one here. So this is a VMware. I don't know why my node's not active, but it should be. So this is just a VMware one that I deployed just before we got on. So let's see if it will tell me why. It is, right, okay, node 1's died for some reason. So I've got 2 nodes in there. But this RAG status is what a lot of ops guys like to know, in that it's showing me that there's a problem, there's something wrong, and it's telling me what the problem is. So if everything on here is red, you know your application's not working. If it's just your nodes, it may just be that one of the nodes that's running your workload. And this is what I'm saying, you don't tend to care as much about a server. What you care about is the service that it's running. So what I wanted to show you was the tools. So in here we've got the alert manager, so you can configure this in here to talk through to your alerting endpoint. So Slack's becoming more and more popular, but it's still got the standards of email. Email's great for those who want to maintain an audit log type thing. So what you can do is when you add a notifier, you can then go in and turn on these alerts. So you can say memory usage of your clusters. If it's constantly going over, you've got an audit trail of maybe it's spiking at a particular type of time of the day or whatever. Having an email of that sort of alert generated sort of allows you to go through and decide what you want to do with that, and gives you sort of the backup to go and say we need more money because we're constantly hitting the ceiling. Logging is where you can go in and create a logging endpoint. So this is where you can go in and customize the data that's sent through and set the endpoint. You can override this at the project level. So what you can say is you can say, okay, I want everything going to Splunk in the initial instance, but actually my VMP, I don't want to blow my Splunk licenses. So if I've got a project with my VMP stuff in, I'm going to send that through to Elasticsearch because it's free. So you can override all of this stuff at a lower level. Then what I want to show you was the catalog. So within the catalog, there's multiple levels to the catalog. So the catalog we enable by default is our own. So these are sort of, I wouldn't say curated, but they are vetted versions or deployments, configurations of these applications. Some of them are actually provided by the vendor, so the Artifactory one's actually provided by JFrog. And what it allows you to do is go in and actually deploy an application with a nice UI, rather than using the standard Helm command, which is just a command line to sort of deploy an application. You can do it via a UI. So this is where you've got the dev and ops split. Ops can actually use this. It's very usable for them. They don't have to understand anything about Kubernetes. All they need to know is what passwords or what checkboxes they should check, and then they can click a launch. Now, when you've actually deployed an application, so if I just quickly, if I do NFS, so to actually deploy an application, I'm just going to click launch, and that's going to go away and actually provision that on my servers. Now, when that's doing it, there's also going to be an upgrade option. So if there was a new version available, it would show it here, and I could choose a different version, and I'd just be able to click upgrade. Similarly, when I've done an upgrade, I'm actually going to be able to use rollback. So again, it makes it very ops friendly in that they don't need to do anything with code or anything else. What it will do is Kubernetes actually keeps a list of all of the things, so you can actually roll back multiple versions. So it makes it very consumable from an ops point of view to allow you to roll back. And again, it's just another way of sort of trying to get adoption within the enterprise. If you walk up to ops with a command line and say, these are the things you've got to do to get this to work, they tend not to be as appreciative as when you give them a nice UI and say, you just click here. So in terms of workloads and everything else, we just manage the workload. So this has gone down as a container. I can sort of shell into the containers the same way you can in any sort of container. And we just give all of that, and you can view the logs from this if there are any. So just give you a nice UI for devs to be able to go in and troubleshoot as well. The other things that we provide, so we provide alerts at the workload level, so I can apply this. So if you've got your own application that you're wanting to deploy, you can put in alerts and say, okay, I'm supposed to be running 3 copies of this, it's only running 2, it'll raise an alert. You can use your own certificates to terminate the ingress. So if you've got a lockdown application that requires certificate authentication, so you're an external service trying to consume one of your internal services that's running within Kubernetes, has to have a certificate, you can terminate it with your own certificate to allow that through. Config maps for passing data through into your actual application. Logging is where you could go to override the logging provider for a particular project. Registries will allow you to specify the credentials for private registries. So if your containers are all stored in private registries that require authentication, you can specify those in here. And then when you actually initiate the deployment of a container, we will check that against these, and if required, we can do the authentication and make sure that it gets pulled down to the servers, so you don't have to do that configuration at the Docker daemon level on each of the servers. And we'll manage secrets as well, so we'll ensure that sort of your database passwords and things are only passed into sort of the containers that it's required to go through into. As I said, we're built on top of sort of upstream Kubernetes, so anything that you use upstream, so if you wanted to use Vault for your secrets, you can, and at some point we are going to integrate sort of Vault management within the UI. It's not there yet, so we're just working on a bunch of features that are sort of going to add some benefit. So if I go back into my clusters now, I can see that my AWS cluster's provisioned, and I've got 3 nodes in there, and that's now ready for me to go away and do deployment. And similarly, if I go into here and do a destroy, a delete, it will go away and it will deprovision those clusters, those virtual machines within AWS, and destroy everything that was there. And that is Rancher in a nutshell. So is there any questions?
One question, Windows containers.
Yes. So Windows containers are going to come in experimental support in our 2.1 release this month. So if you actually run our master branch now, you'll be able to use Windows containers. So the way that they work is they are still going to use Linux for doing the etcd and the control plane, and then you will be able to deploy the agent through to Windows Kubernetes host that will actually run your application workload. So yeah, that's coming. That's there this month.
Any questions? I have one question. In your cluster, it might be a stupid question, but could you have a hybrid cluster? So you got some stuff that's in Windows, some stuff that's in Linux. Is that possible?
I don't know because I've not played with the Windows stuff yet. In theory, you should be able to, because effectively it is running a hybrid cluster anyway, because it's running the control plane and the etcd plane on Linux nodes anyway. So it supports that. What I don't know is how it defines the workloads and how you specify which host it would need to run on. But I'm guessing we've thought about that, so I'd be surprised if, it might not be there day one, but I'd be very surprised if at some point in the future it isn't there.
Cool, thank you. Question?
Yeah, I'm not sure how much sense it makes, but if you're writing, services that you're deploying in the containers, is there any sort of best practice or framework for how to instrument those things for logging purposes, so that you can trace request flow through your service layers?
You managed to get that, Chris?
Yeah. So typically it's done by your logging. So most places that are doing that, you'd have a transaction ID that would be attached through to transaction. That's the only way without really trawling through your logs that makes it easy. So typically what you'd have is you'd have a transaction ID attached in your logs forwarded through to something like Splunk or Elasticsearch, and then you'll be able to do a query to sort of show you what path that had taken. And as part of that, you can have it sort of pass in the container ID and everything else. Most places aren't concerned about hosts, and they're not as much concerned, I would say, about the containers themselves. It's all about the service. So typically what people are doing that for is tracking latency. So they send a sort of a synthetic transaction through the front door and get that back and get a response time. And then what they can see is they can see the path that the transaction's taken. They can see the containers that it was running through. They can correlate that with hosts. So they can see if they've seen a common problem where it's either a particular part of the chain, or if it's a particular host that's having a problem, they can isolate sort of the problem and sort of eliminate it at that level.
Right. Where do people typically generate their, do they have a front-end service that generates the request IDs, or can that be provided through container management or through your ingress layer?
So it depends. So an ingress can inject a cookie, but I don't know if it can. I don't think it can inject a transaction ID. Typically, the transaction ID has to be generated by the application. Okay. So you can inject stuff from the ingress, but I'm not sure of anyone who's doing that. Typically, it's when you hit the front end service, that's when the transaction gets created.
Right.
Any other questions? No? Cool.
Okay, guys, well, thank you for your time. I hope that was useful. If anyone does have any questions, then please redirect them through Leroy. If anyone wants sort of a more in-depth discussion about Rancher, please don't hesitate to get in touch.
Chris, quick one just before you go.
Yep.
Have you got, by any chance, a date when the 2.1 will be released?
Tentatively, I think it's the 28th of this month, but that may slip slightly. But it's due, code freezes today. Okay. So it's as soon as we squashed all the bugs and it's got through QA, basically.
Okay, nice. And it's going to be deployed the normal way, where you can just pull the images down and just run the containers as the current one is?
Yeah, so you can run it exactly the same way. So you can either do a Docker run, which will send you up a single instance of the Rancher server running in a container. So it effectively runs Kube API and etcd within the container. Or you can run it on top of a Kubernetes cluster, and use a kube control and a YAML file to actually spin up Kubernetes. And in those instances, what we do is we adopt the etcd that's part of the Kubernetes cluster, so it gives you that HA piece. But all of the information around running the Rancher server can be found on the Rancher Docs website. So if you go to docs.rancher.com, we cover all of the scenarios for doing the deployment. So single instance, HA, air-gapped, various different types of load balancers, so layer 4 and layer 7. Yeah, all of that's documented on the Docs website.
Cool, thanks a lot.
Okay, thanks a lot, guys.
Thanks. Cheers.
Thanks,
Enjoy the rest of your evening. Take care. Bye-bye.
Cool. Any questions from anyone? Want to talk about anything? Follow the line. Got any ideas? So we not. But we'll talk just now. So yeah, if there's any other questions, one of the ideas for the next meetup was to have someone from Obsidian Systems to do a remote session as well, and we are open for ideas and suggestions for what they would like to talk about. So we're open. Also, we've started. A bunch of us came up with this idea. So there's a GitHub repo. We're looking for contributors. And the idea behind the GitHub repo is to have a safe set of code. So you can check it out. It will be divided into an API, .NET Core API, and a mobile application. The intent for the application is to have a check-in app for meetups like this. So when you arrive, you'll be able to check yourself in, and then we'll be notified, and you can make comments and stuff like that. This is ground zero, so it's greenfield, which is pretty cool. So you can commit your code, your ideas, and there'll be issues and so forth. But the contributors will be given access to the infrastructure that actually runs the application as well. So you can get some hands-on experience on certain concepts and understand or find the pitfalls, and you can take those learning experiences to your companies and tell people that if they're doing it wrong or right, whatever like that. So that's the whole intent for this project. It's starting off, I just thought I'd release it now, announce it now. In the next 2-3 weeks, I'll be starting the API, the .NET Core API, so I'm looking for .NET the mobile developers, because I'm not that good at mobile stuff. So if you're a mobile dev, if you're .NET dev, whatever like that, probably by the end of next month, before the meetups close down, we'll have an orchestrated infrastructure, potentially Rancher, potentially someone else, that will be actually hosting it. DigitalOcean is one of our sponsors, so I'll be speaking to them to give us some VMs. We can actually spin some clusters out. So when the first CI/CD pipeline goes through, you'll actually have something, and you can just ask for access into that infrastructure, as long as you commit some code. We'll have access to it. So yeah, that's one initiative we started. And then if there's any suggestions, please let us know. Reach out on either meetup.com, events.docker.com, or the GitHub repo. I'll be sending out mails with GitHub repo after this evening. Cool. Is there anything that anyone wants to ask, mention? Was it cool? Was it informative? Was it not cool? Should we go a little bit deeper into more things inside the infrastructure or more on the devs? Do you want to see a CI/CD pipeline using containers? Maybe like spin up something, do some integration tests, spin it off, and then deploy it into production, something like that?
Yeah, I don't know. Okay. A lot of people are probably struggling with CI, with pipelines.
Okay, right. One of the people that I'm busy reaching out is GitLab. They have offices in Cape Town and in the States. They have a Kubernetes cluster plugin natively in their product that allows you to do that kind of thing. So I can reach out to them and maybe see if I can get someone to speak from them and show you, do a demonstration of how you can actually do that kind of thing. Okay. Cool, thanks guys, thanks for coming. Yes.
I'm actually, my offices are And I thought that we could Skype in. Skyped in and realised
Oh, that's nice.
there's probably nothing happening or whatever it is. I thought, okay, I've got some time.
I was actually funny enough when you use Canadian, I was trying to tell people that it's going to take a while. So I wrote you a
And I actually figured that you were doing
Yeah.
I used to, I'm from Joburg, I used to go to something called the Doja. Usually starts off with a little bit of schmoozing or whatever it is, and then he gets to the presentation phase. So I thought it just put a little bit of time. I was just sitting down.